Welcome back to Physics with Miyoshi. Today we're going to take a little example from our textbook, Cutnell and Johnson, and we're talking a little bit more about Archimedes' principles. In reality, you can put some numbers to it and find out if we have a solid pine raft, how far it would sit in the water. Boaters would know that as freeboard. Actually, we're going to calculate not the freeboard, which is the amount of raft that's going to be exposed. We're going to calculate how deep in the water it's going to sit. And that's only dependent on the density of our object and the area of our object, and of course the density of the fluid we're going to be in, which in this case is water. So how are we going to do that? Well, first thing we're going to do is we're going to calculate the weight of the raft. Well, why do we need to calculate the weight of the raft? Because we need to find out what the buoyant force is going to be. So, and we're going to check that against the weight of the raft. So the weight of the raft is our rho of our pine times the volume of our pine raft times the acceleration due to gravity. So it's 550 kilograms per meter squared, kilogram per meter cubed. That should be cubed up there. And multiply that by our area, which in this case happens to be 4 meters times 4 meters times our height, which is 0.3 meters. So 4 meters times 4 meters times 0.3 meters. And then multiply that by our 9.8 meters per second squared, which are, of course, is our acceleration due to gravity. We get something like 26,000 newtons. Well, we're going to compare that to our maximum buoyant force. In other words, if I stuck this guy all the way underwater, what is the what's our buoyant force going to be? Well, that's how much water is going to get displaced. So we're going to figure out what the maximum water, the weight of the water displaced by our raft would be. We're going to calculate that again by rho, in this case of our water. Volume, in this case again of our same raft, because we are, as soon as we put the raft in the water, if we stick it all the way in the water, we then displace that much water. And then we're going to multiply that by the gravitational acceleration due to gravity again. So we have 1,000 kilograms per meter cubed, multiplied by the volume of our raft again, and then times 9.8 meters per second squared, and we get 47,000 newtons this time. Well, we want to know if it floats, right? Well, of course, all we have to do is compare the weight of our raft to the weight of the fluid that we displaced, and we see that the fluid displaced is greater in mass or greater in weight than our raft is, so our raft must float. Well, now that we know that it floats, we can then calculate how high it sits or how low it sits in the water by looking again at this equation here. Rho v volume times our gravitational acceleration. Well, we're going to change that v to a times h. The a times h is just because the a is the area of our bottom of our surface, and the h is the thickness of our surface. So surface, well, our object. So we're going to take those guys. That's going to be equal to the weight of the raft. And so that's back here, the 26,000. And then we'll just rearrange that equation to get the height, or the how low it sits in the water. So when we rearrange the equation, we see that the h up here is our weight of the raft divided by the rho, or the density of our water, times the area of the raft, and times the acceleration due to gravity. And so we have 26,000 divided by the quantity 1,000 times 16 meters squared times 9.8 meters per second squared. We get rid of all our units and we end up with 0.17 meters. Now, if we really were going to find the freeboard, which is this distance up here, we could subtract the 0.17 from our 0.3 and see that we are how much is going to be above the surface. But this is a good exercise just to see and how low something that does float sits in the water. And you could calculate that for any boat, any raft, whatever you've got floating in the water. So, a little bit more about Archimedes' principle and how to use some of the equations we've talked about here, and just a little bit more about floating, and maybe a little about making boats and how all that works together. So, thanks for tuning in for Physics with Miyoshi. Hope to see you back again next time.